Hi guys, we're doing fractions these next couple of weeks, and as we're going over fractions, I thought maybe I would go over a few of the concepts that we've already discussed. So one of the things I want to talk about is the word equivalent. And what do we mean by equivalent fractions? Well, equivalent means it's equal. It means the same thing. So for example, let's say I had a bar that was 1/3 colored. Okay, so that's 1/3. 1/3 is the same as 2/6. How do we know that? Well, if I had this bar cut into thirds, by just simply making a line down each of these sections, I now have 1, 2, 3, 4, 5, 6 sections, same bar, but now 2 of them are colored out of 6. So we know that 1/3 is the same as 2/6. What if we didn't have this bar here? How could we get there? Well, one thing you can do is you can decide, how would I go from 3 pieces to 6 pieces? So if I'm looking at 3 to 6, having those 3 chunks, I would divide each one into 2 pieces. So I would multiply them by 2. Multiply 3 times 2 and I get 6. Now, in order for it to be equivalent, we're going to do the same thing to the top. 1 times 2. 1 times 2 is 2. 2/6. They are equivalent. To give you yet another example of equivalent, we can go, let's say 3/5. And we want to make 3/5 equal to something over 15. So in order to figure this out, first I'm going to look at the denominators. What do I do to each chunk? I multiply it by 3. 5 times 3 is 15. So if I had a bar divided into 5 pieces, I could make it 15 pieces by taking each of those smaller chunks and making them into 3 times 3. Now, what do I need to do to the top? Whatever you did to the bottom, multiplying by 3, you're going to do to the top as well. So what is 3 times 3? 9. So when we look at it, our equivalent fractions are 3/5 are equal to 9/15. Now that we know how to create equivalent fractions, we now can do something like comparing. When you compare bars, let's say fractions, that are not divided the same way. For example, here we go, we have 1/2 colored. And here, let's say we had 5/5, and we have 2/5 colored. It's a little tricky to determine which one's which. Granted, my bar looks like it's bigger on the side, but who's to say that I drew that right? Okay, so we want to decide if they are equivalent, which one's greater. To do that, we want to make sure that we make each one into the same amount, the same chunks. So in this case, we have, that's 2. We have 2/5 and we have 1/2. I want to make both denominators a new denominator that's the same in both. I know that 2 and 5 are both factors of 10. So that's what I'm going to do. All right, I'm going to figure out what is the same as 1/2 when the denominator is 10. What is the same as 2/5 when the denominator is 10? Let's go through our little our little strategy to figure that out. So 2, to get to 10, we multiply by 5. So we do the same thing up here, multiply by 5. 1 times 5 is 5/10. That kind of makes sense, right? 5/10, that's half. Okay. 2/5. Well, we're not going to multiply by 5 like we did here. Instead, we've got 5. What do we do to a 5 to get to 10? We're going to multiply by 2. 5 times 2 is 10. Up here, well, if I multiply by 2 down here, I've got to multiply by 2 up here. 2 times 2 is 4. So now, what does that mean? Well, we took each of these little sections and we made them into 2 parts. So now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. 1, 2, 3, 4 of them are colored. Up here, we took each of these 2 parts and we multiplied by 5. We made 5 parts in each one. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 are colored in here, 4 are colored in here. So when we're looking at these, we know that 5/10 is greater than 4/10. But that's not the original fractions we were looking at. Originally, we were looking at 1/2 and 2/5. Well, 5/10 is the same as 1/2, and 4/10 is the same as 2/5. So here is how we are able to determine that they can be compared and 1/2 is greater. That takes a lot of work to figure out. You need to know factors, you need to know multiples, you need to know a lot of information to do it that way. That being said, there's kind of like a cheat. Okay, it's a nice, easy way to do this exact same problem. So I'm going to create those 2 fractions, 1/2 and 2/5. We're going to do something today called the butterfly method. And all we need to do for the butterfly method is we need to basically create this butterfly around these fractions. There's one wing. Notice we surrounded the 1 and the 5, the opposite numbers. We're going to do the same thing here. We're surrounding opposite corners. Then, of course, you're going to have to do a tail. And then we add an antenna. Okay? So what we're going to be doing with this butterfly is essentially we're going to turn 1/2 into a new fraction. We're going to turn 2/5 into a new fraction. But rather than having to figure out, well, I think 2 goes into 10, 5 goes into 10, finding the multiples, figuring out what they are factors of, this will do it for us. So when we're doing the butterfly method, we always know that if we want to add, compare, find equivalent fractions, or subtract, we can use the butterfly method. Add, compare, equivalent, subtract. Those are the methods those are the types of equations we can solve using the butterfly method. We cannot do division, we cannot do multiplication. Now I put a multiplication symbol there. That is simply to tell you that no matter what we do inside the butterfly, we're multiplying. Okay? And I will explain that after we go through the process. So when we're looking at the butterfly, anything within the same oval will be multiplied together. And when we're talking about the tail, we're simply looking at these 2 numbers to multiply to find the tail. So let's do that first. What is 2 times 5? Well, we know from before, it's 10. 10 is going to be our new common denominator. That's the whole goal of butterfly method. Figuring out what denominator should we use in order to find equivalent fractions to compare, add, subtract, or see if they're equivalent. All right, so now we've got our new denominators, but we need to figure out these new numerators. So 1/2 we know is equal to something over 10. 2/5 is equal to something over 10. Now let's look at the individual wings. I'm going to look at the blue oval first. 5 and 1. We're going to multiply these numbers together. 1 times 5. And I'm going to put that number directly above the 1. Not above this number because that's a different oval. I want it above this number here. So 5 times 1 is 5. Looking at the red oval, we're going to multiply the 2 digits in there. 2 times 2. What is 2 times 2? Well, we know it is 4. Again, I multiply, and then I put the number above the tip of the oval that I was using. So these are now our new numerators, 4 and 5. Okay, so remember what we did earlier. 1/2 is equal to 5/10. Remember those bars we drew? Half is the same as 5/10. Over here, we've got 2/5 is equal to 4/10. Again, when we drew the bar and had it divided into 5 chunks, and then I made each chunk into 2, we then found that 2/5 is the same as 4/10. Well, I want to compare 1/2 to 2/5. Which one is greater, 5/10 or 4/10? 5/10 is greater. Therefore, 1/2 is greater than 2/5. Why does this work? Well, let me erase some of this. And we're going to go back to the original way that we figured this problem out. We simply want to find a new fraction to equal our original fractions. This method told us to multiply these two together. If I multiply these two together, I will find a denominator that works, 10. Okay, so that's good. Think about what we did with the 2 and the 5. When we had the 2, we multiplied it by 2. We had the 5, we also multiplied it by 2. So in this case, what we did with the butterfly is we multiplied 2 by 2, we multiplied 5 by 2. What we learned earlier makes sense now, right? As long as you multiply the numerator and the denominator by the same number, we will find a new equivalent fraction. Let's look at the other one, the blue, 1 and 5. 1/2. What did we multiply 1/2 by? Well, 2 was multiplied by 5 to get to 10. We already figured that one out. But 1 was also multiplied by 5 using this strategy, which gave us 5/10. So although the butterfly method is nice and neat and easy and tells us exactly where to go, it all makes sense because what it's basically doing for us is it's showing us what should we be multiplying the numerator and the denominator by to find a new fraction where the denominators are the same. I hope that helps.